to problem number 4 from semester 1 review number 9. Once again, we have a rational equation, and I am going to factor the denominator on the right hand side so that I can find the least common denominator. So I have 1 minus 5 over c minus 3 is equal to negative 30, and factoring c squared minus 9, that's a difference of squares. I can factor it as c plus 3 times c minus 3. So my least common denominator here is the product c plus 3 times c minus 3. And I'm going to multiply both sides of the equation by that least common denominator. So that's going to be, over on the left-hand side, I'm going to multiply by, get a different color here, c plus 3 times c minus 3 times 1 minus 5 over c minus 3, that's the left-hand side, is going to be equal to negative 30 over product of c plus 3 times quantity c minus 3 times c plus 3, let me make that a little bit clearer, times c plus 3 times c minus 3. So now on the left-hand side, I'm going to distribute c plus 3 times c minus 3 to both terms. So I'm going to distribute it to the 1 and to the negative 5 times c minus 3. When I distribute it to the 1, I get the product c plus 3 times c minus 3. And then when I distribute it to 5 divided by c minus 3, the c minus 3's divide out, and I'm left with 5 times the quantity c plus 3. And on the right-hand side, the c plus 3's divide out, as do the term c minus 3, leaving me with negative 30. And now I have a quadratic equation, but I no longer have any terms in the denominator. When I expand this out, I get c squared minus 9, it's a difference of squares, minus, distributing negative 5 to both of these terms, minus 5c minus 15 equals negative 30. I'm going to put all the terms on the left-hand side and combine like terms, so I have c squared minus 5c minus 24 plus 30 equals 0, leaving me with c squared minus 5c plus 6 equals 0. Now I need to factor that. I need to find two terms that multiply to 6 but add to negative 5. Those are negative 3 and negative 2. So I can factor this as c minus 3 times c minus 2 equals 0. Using the zero product property, that gives me the two solutions, c equals 2 or 3. But now I have multiplied both sides of the equation by a variable, c plus 3 times c minus 3. So I need to check if both of these solutions are valid solutions, that is, if neither of them is extraneous. If I look back at my original equation, I can see that c equals 3 will make 5 divided by c minus 3 undefined. So c equals 3 is extraneous, but c equals 2 will be fine. It doesn't make it the denominator 0, so c equals 2 is the solution to this equation.